Welcome back to geometry. We are starting our new Unit 7. First section is 10.1 area of parallelograms and triangles. When we look at the area as just a general definition, it's defined as the number of unit squares that fit inside a plane or a 2D figure. Real quick, before we get into area, we see this term that's called a 2D figure. And so a 2D figure is two dimensions, and it can be our square, it can be our box, it can be our kite, it can be many shapes, okay? When we go 3D, which we're not there yet, but in this unit we'll learn about 3D shapes, we can draw that. It's a box within a box, or a square within a square, or a rectangle within a rectangle, and then we connect all the lines. And so when we have a shape like this, we have our length, we have our width, and we also have our third dimension, which would be our height. So if we were given certain measurements, and when we deal with area, it's going to be unit of squares inside. So we have our base and we have our height, or you'll see it as length and width. And so we'll say that area is equal to length times width, or we'll see it as area is equal to base times height. And so when we solve the area on a 2D shape, our units will be squared, because we could have 6 inches multiplied by 3 inches, and that would give us 18 inches squared. So that's why the area is always squared, because we're multiplying inches by inches, feet by feet, meters by meters. Well, when we get to the area of a 3D shape, it's actually going to be called volume, and it's the number of unit cubes that we can fit inside. And so that's why when we find the volume, if we take, say, 6 inches is the height, multiplied by 3 inches is the length, multiplied by 2 inches is the width, we would get 36 inches cubed, and so units would be cubed. All right, but we're not there yet, so let's jump back to our 2D figures. So if we go by our definition and we extend out this line from 2, and we extend out this line from 1, and then we extend up -2 and -3 and -4 and -5, what we're seeing here is that we can count each of these squares as the area. So the area is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And so we can say, hey, the shape of this area is 15 square units, because we can count and see that we have 1, 2, 3, 4, 5, 6, all the way up to 15. So again, I can say the area is equal to 15 units, and then we can say squared. Now, we can do this for each shape, but this takes a really long time. So instead, we see that we have 1, 2, 3, 4, 5 columns, and we have 1, 2, 3 rows. So instead of just, if we were to count all these up, shortcut is to take 5 times 3. Well, when we think about what 5 represents, 5 is our base and 3 is our height. And so we see that area is equal to base times height. And so that would give us 5 times 3, which is 15 units squared. To find perimeter, we just add up all the sides, and that would give us 16. All right, next shape. We have a parallelogram. Now, when we try and find the area of this shape, it's going to be tough to count all the squares because these lines are slanted. So first, let's think about our base. Well, our base we can count. Our base is going to be 1, 2, 3, 4, 5, 6. And if I count from here, I would also get 6. 6 is out here, so we have 6 as our base. Now, I don't know what this slanted height is, but what I can do is I can draw down a right triangle. And so this amount is going to be our height of our parallelogram. We have a 90-degree angle. We can then count and see that this little piece here is going to be 1, 2, and we can also count up and see that our height is going to be from 0 to 2, so our height is also going to be 2, which means that this piece is going to be 2 squared plus 2 squared equals c squared. So this is our c. 8 is equal to c squared, so I get 2 rad 2 is equal to c. So c is going to be 2 rad 2. Alright, from there, our area is going to be our base multiplied by our height. Our base is 6, our height is going to be 2. That would give us 12 units squared. And our perimeter, we have to add up all of our sides, so we're going to take 6 plus 2 rad 2 plus 2 rad 2, which would give us 12 plus 4 rad 2 units. That would be our perimeter. Alright, so for our formulas, the area, or excuse me, the base of a parallelogram can be any side. However, the altitude must be perpendicular to that side. And so our formula becomes for a parallelogram. This also works for a rectangle. This also works for a square. Is that area is equal to base multiplied by the height. Okay, and again, our base and height can be interchangeable. It just depends on what base and what height that you use. What you'll see on these parallelograms is that we will always have 2 bases and we will always have 2 heights. And it's up to you to choose which base and which height that you'll use. You will always have one answer for the area. However, you will have 2 ways that you can solve. So there's 2 ways that you can solve all these problems. Whichever way you choose, you should always get the same answer. Alright, first problem is an easier problem. We have area is equal to the base. Remember that opposite sides are congruent in a parallelogram. So area is equal to 12 times 4. Area is equal to 48 centimeters squared. Next, we're going to take area is equal to. So in this problem, we look at our height, or excuse me, we look at our base, which is 12. So I can move our 12 down to here, and we have 6 on the outside, so we know that these 2 sides are each congruent as well, and so I can put 6 over here. So at this time you have to choose, or you can have 12 as your base or 6 as your base. So if you use 12 as your base, you do not have a height that's shown that's perpendicular to 12. This height would actually come down here, but we don't know this length. It's an unknown. So we have 2 unknowns. We do not want to use 12 as our base. That would not give us a correct answer. Instead, we want to use 6 as our base, because we see that 8 is perpendicular to 6, and so area is equal to 48 centimeters squared. Alright, next we have a 30, 60, 90 triangle. We're given the hypotenuse. To move to the short leg, we're going to divide by 2. That would give us 4. To move from the short leg to the long leg, multiply by rad 3. Alright, so if area is equal to base times height, I see that my base is going to be 10, and my height is going to be 4 rad 3. Multiply that together, we get 40 rad 3 inches squared. Alright, and again, you could use 8 over here and 4 and 10 up here as well, but we're not sure about this height. Okay, so we want to stick to 10 as our base and 4 rad 3 as our height. Alright, next problem says find the length of the altitude of a parallelogram. The base is 32 and the area is 192. So again, we'll start with our formula. Well, first we're going to start with the area is 192. Area is equal to base times height. So we substitute 192 in. We're told the base is 32. Height is unknown. Divide by 32, and we would get h is equal to 6. Alright, next problem. It says draw one of the diagonals of this parallelogram. And when we do that, we know that opposite sides are congruent in a parallelogram. And that was a very bad diagonal that I drew in, but hopefully you'll see my main point here. By the reflexive property, this segment is equal to itself. Now, let's try and redraw this so that's a little straighter and right down the middle. Alright, that's better. So now, hopefully you can see that these 2 triangles are each congruent. And these two triangles are congruent because of side, 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 side. Okay, and since those two triangles are congruent, this creates two congruent triangles. And so the area of a triangle, you see that a triangle is half of a parallelogram. So if I say it's equal to half the area of a parallelogram, and the area of a parallelogram is base times height, then it's no shock that the area of a triangle is going to be 1/2 base times height. The base can be any side. The altitude must be perpendicular to that side. So the same rules apply with a triangle as they do to a parallelogram, except it's going to be 1/2. All right, let's jump over to the next page. All right, we're back. We're going to solve for the area of the triangle. Again, area is equal to 1/2 base times height. Area is equal to the base, and this problem is 12. Now, sometimes we think that we have to add this amount as our base, but it's not. Okay, they're showing this because when we draw down the height, remember the height has to be perpendicular to the base. So they extended out the base to show you that this is in fact your height. All right, so we enter it in, and that would give us 24 meters squared. All right, moving over to the problem on the right. Again, we have area is equal to 1/2 base times height. A few different ways that we can solve this. If I choose 12 as my base, I look at AE, and I'm told that AE is 3. Okay, so since AE is 3, I can choose 3, and that would give me 18 units squared. Now, a second way that I can solve that same triangle is I can have 9 be my base. And then if you look at 9 as your base, you see that CD, we're told in the problem, is 4. And so you get 9 times 4, half of that is going to be 18 units squared. So again, more than one way that we can solve that triangle. All right, next problem. Hit the pause button if this is your first time seeing this problem, and then see if you can solve this problem. This is a very challenging problem. So again, if you haven't done this problem yet, hit the pause button and solve it. All right, and here's where we could start. We have 100 feet of fencing, so that's going to be our perimeter here. All right, so if I draw a rectangle, and let's say that I went, let's see here, let's go 40 by 40 by 10 by 10, and that adds up to 100 as my perimeter, and area would equal 40 times 10, which is 400, and so that would be feet squared. So that would be one possible garden that I can draw. Let's draw a square this time, and on a square, all sides are the same. We have to add up to 100 to get 25 times 25 times 25. So area is equal to 25 times 25, and we get 625 feet. Well, clearly this has the most area compared to a 10 by 40. And as you play around with other sizes of rectangles, you'll see that a square will contain the most area inside compared to rectangles. There's actually a third shape that I can draw that will have the most area, and it's going to look similar to this. Okay, and if you draw a circle all the way around, you see that you have not only the area of this square, okay, but you also have this area outside of the square, like right here and right here and right here and right here. So if we want to find the area of a circle, we know the area of a circle is pi r squared. However, remember, we only have 100 feet of fencing. So in a circle, circumference is the same as perimeter. So C is equal to 100 feet. Well, if C is equal to 2 pi r, I can work backwards and plug in 100 for our circumference and then solve for r. We divide by 2 pi. We get 15.9 is equal to r, so that would be our radius. So if we have a 15.9 radius, okay, so r is equal to 15.9, that means I can take area is equal to pi times 15.9 squared, and when I multiply all that out, I believe I'm going to get 729 feet. And so clearly, this would be about 100 feet more of area versus a square garden. So if you ever build a garden, I would definitely opt for the circular garden. All right, then our last problems involve the algebra review, and y equals -2. We have this line. X equals 5 is going to be a vertical line. X minus 4, y is equal to 6. That means x equals 6. -4y is equal to 6. Y equals -3/2. X is equal to 6. So x-intercept of 6, y-intercept of -1 1/2. There's our graph. All right, and then our last graph is involving point-slope form. Remember, y minus y1 equals m times x minus x1. Just like our circle, our point will be the opposite. So since it's +1, our center, or not our center point, but our point is going to be -1, 2. And then we're going to rise 2, run 1, rise 2, run 1, rise 2, run 1, down 2 over 1, and we have our graph. Thanks for joining us. See you next time.